Hello. Yeah. Yeah. Audio, video, everything fine? Yes. Good afternoon, Shweta. Hello, Neelam. Now, so we'll be continuing. I think the audio, video, everything is fine. Okay. Yeah. Yes, meet. Okay. Yeah. So let's get started. The topic for today is factorization. So so factorization, mainly three types of questions are seen here. First is three concepts. First thing is you should know how to do prime factorization. Then the second thing is finding out number of factors. And the third thing is number of trailing zeros. That is, you might have heard questions like how many times 10 power n is divisible by it, or number of trailing zeros. Now, the thing is, I have written it here, but how I'll be telling you or teaching you this is in a proper flow. Okay, so everything will flow in a proper way and you will stop seeing them as three different types of questions around factorization. It will become a simple flow. Now, let's get started. So first thing, just understanding these terms. Now, even is what? Anything that is divisible by 2. Odd is what? Not divisible by 2. Prime is only divisible by 1 in itself. Composited has 3 or more factors. Correct? Prime has how many factors? Prime has 1 in itself, only 2 factors. This has 3 or more factors. Now, of course, I wouldn't have written this. So now there are some more nuanced point that we need to know about them. So whenever you see even is divisible by 2. So now if it asks you, if the question asks you about, let's say, number of even factors or anything you want to make even, so what you have to do, it must have sum to the power 2 to the power n, and then anything works, where n is greater than or equal to 1 always. Then if you want it to be odd, you have to ensure that the power of 2 has to be 0, otherwise it will become even. Correct? Now let's see prime. So it is only divisible by 1 in itself. Now one thing you need to remember about prime numbers is, see, if you have to check that a number is prime or not, then what you have to do, you have to first take its under root. For example, let's say I want to check if 101 is a prime number or not. Now, what I'll do, I will first take its under root. So I take its under root, it becomes under root 101 approximately equal to 10. Now, I only need to check the numbers or the prime number specifically less than 10. And if it is not divisible by any of those prime numbers, I know this is a prime number itself. Understood? You don't have to check for all the numbers. You take the under root of that number, you got 10. Now you will check for 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. That's it. These are all the prime numbers less than 10. So I will check for 2. Is it divisible by 2? Very clearly not divisible. Last digit is 1. 3 not divisible. Correct? 5 not divisible. 7 I have to check. 7, let's say 7 ones are with 31. So it will go 4 times. Again 3 will be remainder. So not divisible by 2, 3, 5, 7. I can straight away say that 101 is a prime number. Simple. Okay, so this is how you have to reduce the number of steps to get to prime numbers. Last thing is composite has 3 or more factors. Now, this that you see here, 3 factors can only occur in a very particular case, that is the number, that is the given number is a square of a prime number. This is the only possibility to have 3 factors. For example, let's see 9. 9 has what factors? It has 1 as factor, 3 as factor and 9 as factor. Now, if you take other numbers, for example, let's say I try to take 8, what will happen? It has 1 as factor, 2 as factors, 4 as factor, 8 as factor. It cannot have 3 factors. Why? Because one of the factors will always be 1, and otherwise, so two of the factors are 1 and the number itself, and this is 1 and the number itself. Otherwise, everything in between will occur in pairs. Correct. So here you have 2 into 4 giving you 8. Similarly, always you will get them in pairs. But the only possibility when you don't get a pair of numbers but a single number is when it is a square of a prime number. For example, here what is happening, you have 1 here, you have 9 here, this is fine. But instead of 2 numbers here you have only 3. Why? Because this is square of 3, that is a prime number. Similarly, you can look for any other numbers. This is the only condition that will satisfy. Understood? So this is some things that you need to know. Now we come to prime factorization. Okay, prime factorization. Now 72 and 196. First, let's find the prime factors. Okay, so there is 72. How do you find prime factors of this? Now one method you might know is 72 goes 2 times, then 36 goes 2 times, then 18 goes 2 times, 9, then 3 times, then 3, then 3, then 1. I hope you know this at least. Correct. So this is the prime factorization of 72. What you are getting eventually is very clearly 2 into 2 into 2, that is 2 power 3 into 3 square. This is what you are getting. Correct. Now okay, now 2 cube and 3 square is what you get. Now once you get this, the other way of getting to the same answer is 72 is equals to, now 72 is equals to what? This is also equal to 8 into 9. Correct. This you remember, 8 9s are 72. So whatever you remember as the multiplication of the table which gets you to this, you write it like this and then you try to see. Okay, so now 8 is what? 8 is directly 2 cube and 9 is 3 square. So this is how you can find out the prime factors directly. That is, think of in what table you have heard of them or some multiplication and then try to break it. Understood? Similarly, try for 196. So 196, where have you seen 196? If you must have seen it as 14 square. Correct? 14 square is 196. So what I'll get here? I will get here 2 into 7 and then 2 into 7 more. That is 2 power 2 and 7 power 2. So this is how you get to it directly without doing that whole process. Then now other thing that we need to see is number of factors of n. So once you have learned how to find prime factorization of any number, the next thing is finding number of factors. So first thing, any number in the world, any number, okay, can be written as this, can be written in this form. Correct? That is as powers of prime numbers. Understood? So n can be written as 2 power a, 3 power b, 5 power c, 7 power d, 11 power e, like this. Any whole number can be written like this. Now, if this is so, I ask you calculate the number of factors of n. Okay, so how do you calculate it? One way is of course counting. For example, let's say for 72, I start counting 1, then 2, then 3, then 4. But that is a very tedious process. So the method that we usually use is this. Whatever is the power of 2, 3, 5, 7, 11, all these prime numbers, you just add 1 to them and you just multiply all of them. Understood? Let's take this 72 only. So 72 was what? So 72 was 2 power 3 into 3 square. This is what 72 was. Now you take this 3, this 3 is like a, so 3 plus 1, this becomes 4 into, now 2 plus 1, 2 plus 1 again, because I have to add 1 and then multiply, so 2 plus 1 is 3, 4 3s are 12, that means 72, that means 72 has 12 factors. Simple. So this is the way that we will be counting it. Understood? Now let's see one question. Yes, Smith. Then let x be a positive integer such that 7x plus 96 is divisible by x. How many values of x are possible? Think. So what do you see here? It says 7x plus 96 is divisible by x. Divisible by x means what? When this gets divided, it will give a whole number. This you understand? Correct. Now, of course, 7x by x is what? 7x by x is very simply 7. So this is actually a whole number plus 96 by x. This should come out to be a whole number. Now, if this has to come out to be a whole number, 7 is already taken care of. This also must be a whole number. And when you will have whole number? When you will have whole number? When 96 is a multiple of x. That means, in other words, you need to find number of factors of 96. And this is very easy to find. Number of factors of 96, how you will write? 96, this is 16 into 6, correct? 16 into 6 or 12 into 8, whatever you remember. Now 16 is what? 16 is 2 power 4. 6 is what? 2 into 3. Ultimately what you got? 2 power 5 into 3 power 1. This is 96. So number of factors is what? You will add 1 to the power and multiply each of them. So now see, 5 plus 1, correct? Then here I have 1. Now what I do? Into 1 plus 1. What you get here? You get here 5 plus 1, 6. 6 into 2, number of factors is equals to 12. Simple. Answer becomes C. Understood? Simple. Now yeah, these are just simple questions. Just think about it. It is not of any particular topic. Just think about it, you will be able to find. Let p and q be positive integers satisfying p is less than q. Okay, so p is less than q. Then and p plus q is equals to k. What is the smallest value of k that does not determine p and q uniquely? What is the smallest value of k that does not determine p and q uniquely? Now if you see the options, they are fairly small, correct? Now just think about each of the options. So 3 is what? If 3 has to be written as p plus q, then what it will be written as? 3 will be written as 1 plus 2. Is there any other way? No, there is no other way. 1 plus 2 or 2 plus 1 is same. Now, so you determine this uniquely here, correct? Then next is, so p is less than q, so I must take q as 2 and p as 1. Why? because P is less than Q. So this is the only possibility. 2 plus 1 is not even possible. Then next 4. 4 again I try to write in P plus Q form. What I can write it as? Can I write it as 1 plus 3, okay, and 2 plus 2, but 2 plus 2 is rejected. Why? Because P is strictly less than Q. So then this also determines it uniquely, that is P is 1, Q is 3. Then let's try for 5. 5 is equals to P plus Q. Now this is either 1 plus 4 or 2 plus 3. Now is any of them getting rejected? No. 4 is very clearly greater than 1, 3 is very clearly greater than 2. This is also possible, this is also possible. That means now I cannot determine P and Q uniquely. Answer becomes C5. Okay, then yes Dheeraj, yes Shweta, yes Meet. Okay, now let's see another one. What is the smallest one digit number having exactly 4 distinct factors? 2 is one of the factor, 3 is one of the factor. What do you think? 4 distinct factors. Yesterday only we talked about a very special number, correct? So 4 distinct factors. So let's start looking for one digit number. Now 1 is having only one factor, that is 1. Now 2 has how many factors? 2, 3, 5. Okay, 2, 3, 4, 5, 6, 7, 8, 9. All these numbers are there. Now 2 is a prime number, so it will have exactly 2 factors. Correct. It is saying 4 distinct factors. So 2 is gone. Similarly, prime 3 is also gone. Now 4 is a square of a prime number. So it will have exactly 3 factors. So 4 is also gone. 5 is again prime, gone. Then 6. How many factors does 6 have? 1, 2, 3, 6. Very clearly, it has exactly 4 distinct factors. You need not check the others. Why not? Because it is said what is the smallest one digit number having such a property. So you have found that number, that beautiful number is 6. Now statement 1, 2 is one of the factors, yes. Then statement 2, 3 is one of the factors, yes. Both of these are absolutely correct. Now the question is much better. The question is not asking you according to whatever number you found which is correct. It is actually asking you which statement is required. Now what statement did I use here? What statement did I use here? I didn't use any statement. I could just deduce it directly without using 2, 3. This 6 is the smallest number that has 4 distinct factors. Now it has 2 and 3 as factors or any other factor, does not matter. So question can be answered without any statement, that is D becomes the answer. Yes, Amit. Yes, Amit. Sometimes counting number of possible values, that becomes tricky. Okay. I'll tell you about what, when we end this chapter, I'll tell you about what kind of questions we should need to focus more on and how you won't miss the cases. When we deal with such questions where you have to count the number of cases, we will try to follow a methodical approach. Okay. So you learn about it so that you don't miss cases. Now, here the answer becomes D because you didn't need any of these statements. Then let's see this again. Can you see all these questions are revolving around 2, 3, 4, 5, 6? Just these 4, 5 numbers. This also. See if you can find this. There exists a natural number which, when increased by 50%, can have its number of factors unchanged. Is there such a number? and the other is there exists a natural number which when increased by 150% can have its number of factors unchanged. Now, okay, think. When can you have number of factors unchanged? Just think about this. Two. Two as in you are saying option 2. D. Okay, now see, once you read this question, the first thing that should come to your mind is, when do I have number of factors unchanged? Now, we have read about two things. Prime numbers always have exactly 3 factors. So if I move from prime to prime, number of factors won't change. Correct? Can you feel this? Also, we learnt about that number of sorry, prime numbers have exactly 2 factors. Sorry, that is the number itself and 1. Now, the other thing that we learnt is square of a prime number has exactly 3 factors. So now if the factors have to remain unchanged, then I should either be moving from prime to prime or from prime square to prime square. This is the only 2 possibilities. Correct? Otherwise, if you take composite numbers, if you take a bigger number, for example 72 had 12 factors, but if you compare it with, let's say, 28 or 56, it will have lesser factors. Correct? 8 has much lesser factors. So in composite numbers, as the number size of the number increases, then number of factors will definitely increase. These are the only 2 possibilities for constant. Why I am telling you both? Because this time they have used prime to prime, the other time it is in some next year they may use p square to p square also. Now see, first, there exists a natural number which when increased by 50% have its number of factors unchanged. Yes, an example of this is 2 and 3. See how? So now you have 2. This is increased by 50%. 50% increase means what? 100 plus 50 by 100. That is what? That is equals to 2 into this is 1.5. 1.5 into 2 is 3. Now 2 is a prime number. Yes. 3 is also a prime number. Yes. Number of factors exactly 2 didn't change. This is correct. Then there exists a natural number which when increased by 150% can have its number of factors unchanged. Yes. 2 and 5. If you take 2 and now increase it by 150%, this becomes 100 plus 150 by 100. This comes out to be what? 2 into, this is 250 by 100, that is 2.5. Answer becomes 5. Now 2 was prime and so was 5. Both of them have 2 number of factors. So this also is absolutely correct. Answer becomes both 1 and 2. Now, okay, so what you got? Both 1 and 2 becomes the answer. Then, now, before we do this, there are some note points that we need to do. Now, number of factors, I hope you understood how you calculated. You simply have to write the prime factorized form, and from that a plus 1 into b plus 1 into c plus 1, you get the number of factors. Then some tricky questions also we have seen. Now let's get to the note points. Okay, now all these note points I have been teaching for a very long time, but the thing is they didn't ask. I was always hoping that they will ask questions based on these. In 2025 they did ask, and I expect that they will ask more questions that are more nuanced That is, instead of asking number of factors, which is very like one liner or something that you learn as a formula, they will ask some better questions that requires understanding of factors. Now see, number of even factors, what you have to do, if number of factors you can calculate very easily. If I ask you how many of those factors are even in nature, how many of those factors are even in nature? Now how do you find that? See what I have written here. What you have to do, you have to just take 1 2 out and then count. Why? Because this is an even number. So if I take 1 2 out, now whatever remains inside, it may be an even number, odd number, whatever number, it will always lead to a even factor. Can you feel this? Because 2 into any number is always even. Correct? That is why we wrote that in the when we were learning about what are even numbers. Now you see here 144 is 16 nines are correct. So 2 power 4 into 3 square. Now I am asking you number of even factors. So what you will do, you will first take out 1 2. 1 2 is taken out. What remains? 2 power 3 into 3 square. Now for this you can do the same process as we were doing before. So I do the same process here. Just forget this 2. Forget this 2. You have taken this out just to make everything even. Now this you have to count number of factors. So this is what, from here what you will take, 3 plus 1, correct, into 2 plus 1, correct. 3 plus 1 is 4. 3 plus 1 is 4 and 2 plus 1 is 3. So 4 3s are 12 becomes your answer. This is the number of even factors that 144 has. Understood? Simple? Yes, meet. Correct. So this is what you have to do. You take 2 out and then do the same process. Now, if they ask you number of odd factors, now what you have to do, you just take power of 2 to be 0. Whatever power is given does not matter, you take it to be 0. Now whatever is left you calculate for that. For example 84, I ask you number of odd factors that 84 has. So 84 is what? 84 is 21 into 4, correct. So 3 into 7 into 2 square, that is 4. Now so first thing what I do, I take 2 power as 0. Then whatever is left, so 2 power I0 I take as 0 and then I just cancel it out, does not matter to me. Now what remains? Only 3 power 1 and 7 power 1 remains, correct. So 2 power 0 I have taken, or I just remove 2. In other words, I have to forget about 2 at all, correct. So you can just hide it like this. This is one way, or you can think of 2 power 0 is the fixed number. Now if you just hide this, what you have? 3 power 1 and 7 power 1. Now number of factors will be what? It will be 1 plus 1, that is 2, into 1 plus 1, that is 2. 2 into 2. 4 factors of 84 are odd in nature. Understood? Odd how you calculate, even how you calculate. Then now let's see this. This is maximum power of a composite number. Okay, one very specific example of this is actually calculating number of trailing zeros. Now number of trailing zeros, how you get zeros at the end? Basically whatever is the maximum power of 10 in a number, that is the number of trailing zeros, correct. If any number looks like, let's say 848,000, now this number of trailing zeros is actually equal to what? Is the power of 10 itself now. So this is 848 into 10 to the power 3. So how many trailing zeros? 3, correct. This you understand very simply. So both of these are actually the same thing. Now how do you calculate number of trailing zeros? So you need to understand, to create a 0 or to create a 10 is a composite number. What do you need? What do you need to create 10? You need 1, 2 and 1, 5. Correct? This is what is needed. Now, who will decide? Will 2 decide the number of zeros or will 5 decide the number of zeros? Is based on whatever is the limiting case. Correct? For example, let's say I am trying to make coffee. Now, to make coffee, I need milk and some coffee beans. Now, how many cups of coffee can I make? How many cups of coffee can I make? Now, if I have very small amount of beans, let's say I have only 10 grams of bean and I have gallons and gallons of milk, then what is the deciding factor of how many cups of coffee I can make? Correct? Beans is the deciding factor. Why? Because bean is in less quantity. Similarly, if I have large quantity of beans, but I have only, let's say, 1 cup of milk, then how many cups of coffee can I make? I can make only 1 cup. Why? Because milk is not available. So whatever is less decides the number of cups of coffee that I can make. Now here, instead of this C, you have 10 and this is 2 and this is 5. Now whichever is in limited quantity will decide how many 10s can you make. Understood? So now limiting case is 2 or 5, whichever is the limiting case, that will decide the maximum power of 10. This you understand? Now, yes Amit. Yes, yes. Then if prime factorization is given, now sometimes in questions they may give you the prime factorization directly. So what you have to do, you have to just take out the required composite number and then count. For example, see this, 84 is 2 power 3 into 3 power 1 into 7 power 1. Now if they ask you number of factors of 84 divisible by 6, number of factors of 84 divisible by 6, what you will do? You will do a very simple thing. Like there we were taking 2 out, correct, for even numbers. Now here you have composite number, does not matter. 6 it is saying, so just take out 6. Take out 6. So if you take out 6, what you will get? 1, 2 and 1, 3. You take out like this. So what remains inside? 2 power 1 into 3 is gone, 7 power 1. This I am cutting because I have taken this 6 out. Correct? 6 I have taken out. Now I have this, that is 2 power 1 and 7 power 1. How many factors can I form from here? 1 plus 1, 2 and 1 plus 1, 2, 2 into 2, 4. That means 84 has 4 factors which are divisible by 6. Understood? 4 factors it has which are divisible by 6. Now, if you have understood all this, then we can do more questions. Yeah. How many zeros are there at the end of the following product? How many zeros? First thing you see here, that which is, see, for number of zeros, how many zeros means what? Number of trailing zeros. That means I am looking for power of 10. Correct? I am looking for power of 10. For 10, what do I need? 2 and 5. Now, whichever is the limiting case, that will be deciding the number or the will be deciding the power of 10. Correct? Whichever is the limiting case. Now, you see here, okay. Now, if you see here, you can guess that 5 is available very easily. Can you see 5, 10, 15, 20, 25, 30, 35, 40, all of them have 5. Correct? So mainly this will depend on 2. Can you feel this? Correct? So this will depend on 2. Now you can directly start looking for power of 2, or you can just calculate for 5 and 2 both. Now let's see here. So I am writing here 5 power is what? So 5 power is what? Let's see. So here I have 5 power 1 now. Again 1 5 is here. Then in 15 also I get 1 5. In 20 also 1 5. In 25 I get 2 5s. Can you feel this? 5 into 5 is 25. Then in 30 I have 1 5. In 35 I have 1 5. In 40 also 1. In 49 also 1. In 50, how many 5? This is 25 into 2. So again I have 2 5s here and 1 in 50, 5 and 1 in 60. Simple. Now you just add them all. So 1 plus 1 plus 1. This is 3, 4. 4 plus 2, 6. 6 plus 4. 6 plus 4, 10. 10 plus 4, 14. So you got 5 power 14. Correct? Now into what is the maximum power of 2? So let's calculate maximum power of 2. Now no 2, no 2. Here I get 1, 2. Then 15, no. I only have to look for even numbers. Correct? Now 20 has how many powers of 2? This is 4 into 5. So it has 2 power. Then after this 30. 30 is only divisible by 2. Correct? So I will get only 1 here. Then 40 again divisible by 4 as well as 8. Correct? 2 cube into 2 cube, that is 8 into 5. So this is divisible by 8 also. So I get 3 here. Then 45 is gone. Then 50. Is 50 divisible by 4? No. So that means only divisible by 2. I will get only 1 here. Then 60. 60 is divisible by, 60 is very clearly divisible by 4. Is it divisible by 8? No. So here also I will get only 2. So what I got? 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 3 is 7. 7 plus 1 is 8. 8 plus 2 is 10. Yes, Dheeraj. Yes, meet. So ultimately, which is minimum? 14 or 10? Of course, 10 is minimum. This is the limiting case. Answer becomes A. Okay. 5 I have counted only for you to see. Otherwise, just by looking at it, you should get a feel that 2 will be the limiting case. You count 2 directly, get to the answer. Okay, fine. Now, let's move forward. Let's do this. 15 into 14, 13 till 1 is equals to 3 power m into n, where m and n are positive integers. Then the maximum value of m. Maximum value of m. So what you are looking for? What you are looking for? You are looking for how many 3's can I take out from this whole thing. So the question becomes, how many 3's can I take out from this? This is the question. How many 3's can I take out from this? How many 3's? What do you think? So if I write it, so just think, what are the multiples of 3? Those are only important to us. So basically 3, then 6, then 9, then 12, then 15. I have rejected all other numbers. For example, 13. Does 13 have any 3? Does 14 have any 3? No. They are not even multiples of 3. So in this only I have to look. Now, how many 3's? So here, of course, 1 here. Then in 6 also 1. But in 9 I get 2 3's. In 12 I get 1. In 15 also I get 1. I add them all. 1 plus 1 2. 2 plus 2 4. 4 plus 2 6. So I add them all together. And this becomes what? This becomes equal to 6. So this is the maximum power of 3 that is possible. Answer becomes B. Now. Yes, Dheeraj. Yes, Shweta. Okay, now one more question that I am expecting based on this is what Amit was trying to ask, that is number of factors, number of values of m. Now, if the question was, what is the, now see, I am amending the question, what is the number of possible values of m? If this is the question, then tell me the answer. It is in these 4 only. If this is the question, what is the number of possible values of m? Same question. Everything else same. Now tell me the answer. Of course, m is equals to 6 is one of the possible values. Are there any other possible values as well for m? No, Smith. Think. Of course, m is equals to 6 is possible. Is any other value also possible? Shweta 3. No. Okay. See. Now, the question actually does not tell you anything about n. It does not tell you anything about n. Correct? Now, because it was asking the maximum value of m, so that's why all the three that this expression had, you allocated it to 3 power m. Correct? Because you were finding the maximum value of m. So, maximum value of m is of course 6. But there are other values also. What are other values? I can do one thing, that let's say I have 6. I have 3 power 6 here. That is, this whole expression has 3 power 6. Now, how do I allocate this? So, I allocate it like 3 power 5 into, now into this n, whatever was the value, this actually has 1 3 in it. So, this n is actually 3 power k form. This is satisfying? Correct. Now, k is not a multiple of 3. Correct. Now, I have given only 1 and one more possible value of m I got is 5. Similarly, I can also give, for example, 3 power 4 into 9 some other k dash. Does not matter. Correct. N can be anything. N can be any number. So here, what value of m I got? I got 4. I can also give, I can also have 3, I can also have 2, I can also have 1, I can also have 0, because there is no restriction on m. So whatever 3 power 6 I have, I will give it all to n, and then m will be equal to 0. So all these values are possible. So number of possible values is actually equal to 7. This is the number of possible values of m. Yes, Dheeraj. Understood? Okay, so this is something that I am expecting. Then let's move forward. Smith, see, m can be anything. Now n, I have no restriction on m. So maximum power of 3 is of course 3 power 6 on both sides, but how it is allocated can be different. Correct. Here, because it was asking maximum value, so I allocated all the possible power of 3 to this m, and I wrote the answer is 6. But I may have only 3 power 5 here, and one of the 3 I give to n. Does not matter. Correct. For example, see. I don't know the value of this, but let's say it comes out to be like whatever this multiplication, this was equals to 3 power 6 into 1 1 2, let's say 1 1 1 1 2. Correct. This is like that number. So 3 power 6 into whatever was remaining. So this was my 3 power m, this was my n. Now another way of writing the same thing is 3 power 5 into 1 3 I give here, does not matter, n can be anything. So 1 3 I give here, it becomes what? 3 3 3 3 6. Can you feel this now? This is also a possibility. Now instead of this, I can give one more 3, then one more 3, like this. All different values of m are possible. Understood? That is 0 to 6. 0 is the minimum, 6 is the maximum. Why? Okay, now Next, what is the maximum value of n such that 7 into this is divisible by 35 power n? By the way, when we are taking 0 here, it says m and n are positive integers. So if you take positive, then you will have to remove 0. Then the answer would be 6. If you consider all possible values of m, that is not considering m and n are positive. Let's say if, let's change this also. The question was, if m and n are non-negative integers, then you will have to count 0 as well, and then the answer becomes 7 for that particular case. Then now do this. Again, what do you think? 35 power n? Correct. This is not like trailing zeros. This is using the core concept, that is of composite numbers. Composite power n will be exactly same. So 35 means what? 35, you are looking for 5 and 7. Whichever is the limiting case will decide. Now, if you see this number, what you can feel? 7. This is 7 cube. Correct. Then this also is divisible by 7. Correct. Then this also is divisible by 7. Can you feel that 7 is more prevalent? What is missing? What is present in very low quantity? That is 5. So in all probability 5 will decide it. Correct. Now let's see. So 5, where do you see 5? I can see 1 5 here. Can I have 25 here? No. 25 goes like 25, 50, 75 and then 00. So 85, of course not. So here I get 1 5, then 1000. 1000 has how many 5s? So you take 1000. Let's say you divide this by 5. This becomes 200. Again divide by 5. This goes 40. Again divide by 5. And this becomes 8. Now this is of course not divisible by 5. So what I got? I got 5 power 3 here. Then 2401, no. 4 times 7, no. So how many I got? 1 plus 3, that is 4 is the limiting power, or 5 power 4 is what I'll get. Once you want to check for 7, now you can also see this is 7 power 1, this is 7 power 3, this is also 7 power 1, this is also 7 power 1. Already you have crossed 5, 6. Correct? So that means this is not the limiting case. B4 is equals to answer. Yes, Dheeraj. Correct. Now, this you can take as homework. Same process you have to follow. Now it is asking you number of consecutive zeros. So again, you have to look for 2 and 5, whatever is the limiting case, and that will give you the answer. Then now see this. This is a good question. Think about this. At least read it, think about it, then we'll discuss. Okay, at most places that I saw solution of this question, so they have said that this is a trial and error based solutions. Now those are not very good. There is actually a proper solution from which you can reach here. They are just giving some trial and error. Now after the exam, if you are sitting, by trial and error, by chat GPT, something you will find. Okay, and then they are saying, see, this is satisfying, so this is the answer. That is not the way. LCM of 2430. LCM is of two numbers at least. Now let me tell you, okay, if most coachings are not giving proper solution, of course you won't be finding it as well now in this 10-20 seconds. So the thing is, by trial and error, if it fixes for you, then it's fine. But let's understand how you can do this in a methodical way. Now first thing, you see here, you see a 0. How can you get a 0? How can you get a 0 at the end? How can you get a 10? That means if P is a number and Q is another number, okay, they must have one of them must have 5 as unit digit. Can you feel this? One of them must have 5 as unit digit and the other one of them must have an even number as a unit digit. Can you feel this? This is the only possibility when you can get 0 at the end. One is 5 must be the unit digit of one number and even number must be the other unit digit. Correct? So basically even number must be the other number. Now P and Q are also reverse of each other. So I assume P is equals to x5. Why I assumed like this? Because I need 5 as the unit digit. Now if P is equals to x5, what is Q? Q is just reverse of this. So Q is equals to 5x. Correct? Now P into Q is equals to 2430. So that means x5 into 5x is equals to 2430. But this is not the very good way to write this, because actually this is place value form. Correct? So x5 is equals to what? This is what yesterday we have learned. So this is 10x plus 5. And what is Q? Q is 50 plus x. This whole thing is equals to 2430. This you can feel. Now you can solve this for x if you want, and it will be a proper solution. Okay, that will be a proper solution. But now let's see another way of getting to this faster. So P is x5, Q is 5x. You know one more thing about x, the other digit has to be even. So x belongs to even. If x belongs to even, what are the possibilities? Either it is 25 into 52 or now 25 into 52. Now this is what 2430. Correct? 50 into 50 is 2500. Correct? So very close to this. Now this is much lesser. 25 into 52 won't be the answer. Then next you look for, next is 45 into 54. If you check this, 45 into 54, this is slightly less than 50, this is slightly more than 50. If you multiply them, you do get 2430. That is why this is the answer as well. If you want to check, you can also check 65 and 56, but this again will be much greater than 2500 also. This is greater than 50, greater than 50. So this is also not the answer. Similarly 85 and 58, whatever, all this will become much bigger numbers. Only possibility is 45 and 54, 2430 they are giving. Then it is asking the difference between P and Q. So if P is 45 and Q is 54, what is the difference between them? 9. So answer becomes D, that is 9. Okay, understood? It is asking you difference between P and Q. Okay, Smith. That's why you cannot just pick 45. Correct? It is asking you difference between P and Q, which will be 45 minus 54 minus 45. That is 9. It is not asking you P and value of P and Q. Okay. Then now let's see another. So one thing you learned from here is, you see a 0, you immediately think of 5 and 2. So one digit has to be 5, other digit has to be 2. These are the two possible unit digits. Then similarly, let's see this also. This also people do it using trial and error. Correct? So P plus Q into R plus S, you have to maximize. Think about it. Think about a process. PQRS are distinct single digit positive numbers, then what is the greatest value of P plus Q into R plus S? See, one thing you understand, PQRS, if they are distinct single digit positive numbers, you want the greatest value of them. So at least this you understand that you will pick the 4 greatest single digit numbers. This you understand. So PQRS will be chosen from which will be with, and that I'm not claiming, will be chosen from 9, 8, 7, 6. Can you feel this? Correct. So they have to be chosen from these 4 numbers. Now how will they be arranged? You can do the arrangements and then find out which is the maximum, or I will tell you something, that whenever sum of a set of numbers is fixed and the product has to be maximized, then what you should be choosing? Always try to make them equal or very close to each other. Okay, always it is maximized in this way if the sum is fixed. Understood? Now, so basically according to this, P plus Q into R plus S will be maximum when this and this are equal. When P plus Q and R plus S will be equal. Now, can you think of a possible case when this can be equal? Only possible case is to take 9 and 6 together, the 2 bigger ones, and then you take the 2 middle ones. Both of them are giving you sum as 15. So 7 plus 8, so you can take any. So one sum will be 7 plus 8 and the other will be 9 plus 6. 9 plus 6 is 15, 7 plus 8 is also 15. 15 into 15, this is 225. This is the maximum value without any doubt. So answer becomes B. Yes, Meet. Yes, Dheeraj. Yes, Tingda. Understood? Simple. Now, next thing is counting of digits. Okay, so you have pages to digits or digits to pages. Now, do we have time? No, I don't think we have time today. Okay. Okay, we'll continue from here, from this topic tomorrow. That's it. Thank you. If you have any doubts in all, you can ask on Telegram, or if you have just now within a few seconds you can tell, I will try to clear them. Okay, that's it. Thank you.